hydrological analysis. My name is Kraspos Kujinga. I'm the programs coordinator for WaterNet. I see Dr. Subira Munishi is now with us on the platform. I will ask you to take over and take us through the session. Thank you.
Thank you so much, Kujinga. Hi, everybody. My name is Dr. Subira Munishi from University of Dar es Salaam. And I also have my other colleague with me, Frank Anderson, who will be taking you through today's session and tomorrow and the Friday session as well. So you are all welcome. I think we are ready to start. Are we ready to start? I'm not sure if people are here.
Yes, we can hear you.
All right.
Yes, Dr. Subira.
Thank you so much. Are you able to see my PowerPoint?
Yes, we can see.
All right. So today we'll have a little bit of kind of two sessions that we have divided. The first one is just to introduce you to water budgets and river basins. And then the second one will also introduce you to what we'll be using, QGIS, introduction to QGIS, so that when we start working on the data set, it will not be difficult. So I'll be taking you through this. So number one, we'll have a review of water budgets in river basin. And then we'll look at the data that we can use for water budget estimation. And then we'll also look into global land data simulation system. And then we'll also look at the case study that we are going to use for this time, the Limpopo River Basin. So we expect that at the end of this session, you'll have gained a little bit of insight on the water budget in river basin, not that detailed because it's just a one-day session anyway. But also you'll be able to differentiate different kind of remote sensing products that you can use to estimate water budgets in river basins. So I thought we should first start with a review of water budget and a river basin. What is a river basin? So we are actually looking at a land that drains water into a river and its distributaries. Whenever we say a river basin, that's what we mean. And normally we expect to have multiple drainage catchments and watersheds that are separated by ridges. And so we say that we have different watersheds that are divided by maybe a water divide or a ridge that form a water basin. And each watershed in a river basin collects rain, whether it's rain, whether it's no water, and drain it into a common outlet that we call a river or a stream. I was hoping that most of our people here will have a little bit of idea on hydrology. So a drainage basin basically consists of surface water, but also underlying groundwater, subsurface water systems. Now, why is it important to manage a river basin? Why is it important? We may need to do water allocation. We may need to share our water among different, riparian states or regions or countries. For whatever purpose, we need to understand the underlying conditions. We need to understand what do we have, what how much water do we have and how much water can we allocate? How much water do we have at a certain season? How much water do we have at a different season? So we need, like in Africa here, or in the world right now, we have 263 transboundary river basins, which are covering roughly, this is roughly half of the Earth's surface. And what that means is, when you have a transboundary river, the decision to use that water does not entirely rely on yourself. So you must be able to also share the information and make a decision together with your neighbor, country, or state. Now, already we have 145 states that have territory within transboundary lake and river basin. Tanzania, we have a number of river basins. In Southern Africa also it's the same. So because we have this kind of large river basins, and they are not just lying within your country alone, but you need to still make decision on how to use that water, and you still have to make a decision that will not harm another person. You might like to go into data sets that are not just relying on ground data sets. This is why we use remote sensing of satellite information, so that you are able to be totally well informed. Like in Tanzania, we have Lake Victoria Basin, and we're sharing it with Kenya, Uganda, and Tanzania. It's not possible when Tanzania wants to make a decision to know everything that is in Kenya, everything that is in Uganda. But satellite data or remote sensing techniques have been helping us a lot in making decision on how to use and allocate this water without, bringing harm to another state or riparian state. So river basin management, if you want to manage water in a basin, very important, you need to understand how much do you have. It's like a bank. How much do you have? What is the storage? What is available? And in different seasons, what is available? And we have different influences. This availability of your water is influenced by many different factors, like weather, climate, the soil cover, the way the population is and where they reside and all those things. So all this information, you want to understand the characteristic of your basin. Sometimes just the ground data set may not be enough. Sometimes it's inadequate. We have a lot of engaged basins, in Africa and also in Tanzania, but I know also in Southern Africa, we have a lot of basins that are not, fully gauged. This is when now you need to go for satellite information, or to be able to use it together with the ground information. So number one, maybe you want to do is first delineate watersheds. We will try to go into that, though I'm not sure if we'll have time for much of that. But first, you want to be able to know the boundaries of your basin. And then you also want to know about the characteristic of your basin. Things like soil, vegetation, the surface water, the subsurface, what are the interactions like? You want to first understand those things. Things like the land use, the land cover. You want to be able to understand that. And what is demanded, what is needed, what is the demand, whether be it domestic demand, be it industrial demand, what is the demand for that water now in all those basins, or maybe if it's a transboundary basin, it becomes even more sensitive. So in this session, this today, tomorrow, and also Friday, we'll focus on using remote sensing techniques for estimating water budget components. I hope we're together to that point. Are you able to get me?
Yes, we can get you.
Yes.
Okay. All right. So satellite data and remote sensing techniques become very handy in monitoring availability. Because availability is a function of time, it also changes. Function of space also changes with space. So it's something that availability is not, you have changes spatially, but also have changes seasonally also. So it becomes very crucial at this time. And when we talk of water budgets, these are things that will control what is available and evaporation, transpiration, infiltration, surface water, groundwater storage, how much runoff do we have? All these things they control. They actually control the availability of water. Now, in estimating our water budget, we want to be able to look at our main source of water in this basin is precipitation.
Hello, Doc, are you there? Looks like we have lost here. Hello, Doc, you are muted. You are back, but you are muted.
Okay, are we together now?
Yeah, maybe you can remove your video.
Yeah, maybe because it makes life tough here. Okay, my internet. So I don't know, I was cut from.
Yeah, that's
okay.
That's the point you were cut off on that slide.
Okay. All right, so I was talking about why we need to understand the river basin water budgets, and I was saying that, you know, our main source of water in our river system, in our basins, is actually rainfall. And in water budgets, we want to be able to partition how much of the rainfall that is coming in goes into, the percentage that goes into evapotranspiration, the percentage that goes into subsurface or surface discharge, and another that goes into storage. We can do this rough estimation with satellite images or remote sensing data sets. And this is what we want to take you through this remaining day. Okay, all right, great. We have a number of sources that can give us this kind of information, the water budget components. Let's say we start with precipitation. We have a number of sources that can provide precipitation data sets to us. We have selected for these 3 days. We are going to use TRM and GPM. And these are data sets that are available from 2000 up to now. And they are available at 30 meter, but also daily and monthly temporal scale, but also spatially. Our grids are 0.1%, 0.1 degrees, sorry. We'll also be able to look into evapotranspiration, which it's actually a MODIS data set, and it starts from 1999 to 2002. And these are 500 meter spatial resolution that are provided after every 8 days. And we also have the annual data sets. We'll be able to also to use GRACE satellites for terrestrial water storage. And this one spans from 2002 up to 2017. These are monthly data sets also. All right. ground observations, the water budget components that we're interested in. And land data simulation system actually integrates data from multiple ground and space-based observation systems to be able to actually model the water and energy fluxes that we use to infer things like soil moisture, temperature, and evapotranspiration or surface runoff. We have a number of databases that are in it. We have the Global Land Data Simulation System, GLDAS, and we have the North American Land Data Simulation System. We have the Farming Early Warning System, which is a FuseNet system. And we have the NCA LDAS, the National Climate Assessment Land Data Assimilation System. All of these are actually available in this website. So it executes globally up to 1 kilometer resolution, all right? And it uses a number of land surface models, basically to be able to drive the water budget components that as hydrologists or water resource engineers or water resource managers we're interested in. And the temporal resolution of these data sets that we'll be looking at is actually 3 hourly data sets. And we also have monthly products that are actually aggregates of these 3 hourly products. We have version 2.1 and 2.2. Okay, both of the models use vegetation mask and land or surface mask and leaf area index from MOLIS. And just want to go to, they are available from 2000 and version 2.2 is available from 2003. So the inputs for the models are precipitation, the surface radiation, and the meteorological data sets. And the outputs that we are interested in is actually precipitation, evapotranspiration, surface and subsurface flows, and water storage. Version 2 gives us the water storage runoff and evapotranspiration. The main difference is actually on the spatial and the temporal resolution of version 2.1 and version 2.2. We will be running for these 3 days. The Limpopo, will be looking at Limpopo River Basin. We selected this because it's a transboundary basin. And it actually includes these countries, 4 countries. And that gives you an idea of why you actually sometimes need to use satellite data sets, because when you need to make decision around such a massive, huge basin, if you just rely on ground data sets, that is going to be very tough. We're going to appreciate how much satellite data and information system can actually help us to quickly understand this Limpopo River Basin, even though some of us, maybe you have never gone there, but you still have a lot of insight into this system. And I think for now, I'll stop at this point and be able to take your questions as we are, before we go into the second version, which will be introducing you to QGIS, a platform that we'll also be using. Thank you very much. Hello, is everybody here? Oh, yeah.
We are here, Doc. I'm not seeing any questions in the chat box. If there is anyone, okay.
I have a question.
Okay, you can go ahead.
Yes.
Okay. You have mentioned a number of data products, like sites where we can access the data that we can be using, let's say maybe for delineating watershed, like the GLDAS. So I just wanted to learn from you that these sites, are they open source, or maybe you're supposed to purchase the data products?
These are open source. Though some
Okay.
of the models that they were using, they are not open source, but already they have processed most of the data. And so these are open source data sets. We'll be able to just get them easily.
Okay, okay, thank you.
Thank you so much.
Hello, Dr. Subila. Can I add up?
Yes, please.
Okay. All data sets that we will be using are open source, but we will see about GLDAS version 2.1 and 2.2. They are using forcing. So that data that are used for forcing are not open source, but GLDAS specifically are open source. I hope it's clear now.
Yes, thank you.
Thank you so much. So what do you think if we go into the second session? Because time may not be so much with us.
Okay, that's fine, Doc. Let's proceed.
Yeah, maybe more questions will continue coming in as we move on. Okay, so Frank, you can take them through the second session, please. Frank Anderson is with us. The University of Dar es Salaam is in a collaborative project that we have, and he'll be also in this session for the coming also 3 days. Thank you. Frank, you're welcome.
Okay, thank you very much, Doc. Let me share my screen first. I hope everyone is able to see my screen.
Yes.
Yes, yes.
Okay. So by introduction, my name is Frank Anderson. I'm a data scientist by professional, and I'm from University of Dar es Salaam. Basically, I'm collaborating with University of Dar es Salaam in partnership with Moi University, Kenya, and Makerere University in Uganda to help in building capacity to fresh graduates, specifically water engineers. So particularly, I'll be moderating the demonstration part of all the sessions. So for today's sessions, we'll be looking forward at the basic introductory part to QGIS. And what we will cover, we will get to know QGIS in general, then we will see how to download it for those who don't have it. Then we'll see how to state a project in QGIS, we'll see how to build its plugins, how to add data, both vector and raster areas. We will see how to manipulate style, colors, and symbology in QGIS. We will see how to use different processes in QGIS using processing toolbox, and we will see how to deal with projection. So the prerequisite of this course is just to understand. You must have a general understanding of GIS. You must have QGIS installed in your computer, which you will do, and you must have data. And for this case, you must have your properly Basin shapefile. So a preamble, this is a brief introductory exercise to QGIS, and these are practical skills that will complement the exercise of water budget estimation using remote sensing dataset, and GLDAS, which is Global Land Data Simulation System. So you should consider this manual as a prerequisite of the practical exercise for water budget estimation. So what is QGIS in general? QGIS is a user-friendly open source geographic information system, and it is licensed under the open source license. So QGIS supports a variety of operating systems from Linux, Unix, Mac, Windows, even on Android you can do a variety of processes. Also, QGIS supports a variety of data formats from vector, shapefiles, images, raster, different database formative. And basically, QGIS is a volunteer-driven project. So basically, anyone can contribute to the source code for QGIS upon validation. Anyone can try to fix bugs from QGIS. You can report bugs. You can contribute to development of training documentation. You can support others through this platform. So QGIS has aggregated in the two main types. It is embedded in the core functions, and it has also plugins. So plugins are just third parties applications that are used to enrich the functionality of QGIS. So basically, you can visualize, you can manage data, edit data, analyze data, and even compose printable maps using QGIS. So first, we will start by looking on how we can download QGIS, and I will demonstrate it. So you can just visit at this web page. So this is the main page for QGIS, the free and open source geographical information system. So just scroll down and select and download now. And to download QGIS, you must have an understanding of your computer operating system and system type. So if it's Windows, you can use this tab. If it's Mac, if it's Linux, etc. So myself, I'm using Windows, and it is a 64-bit system. So I will expand this tab for Windows and just scroll down and select on a QGIS standalone installer version 3.1.6, which is 64-bit. So I'll just click this, and it will pop up an option to save this file. So as I will click this file to save. So as you see, I will save this file maybe to download, and you can rename your file here. Just click save, and it will start downloading, but I will not download it because I have already done so. So basically, after download is finished, you can click it to open so that you can install QGIS into your computer. I will not go to installation part, but I will just show you to this manual on how you can install. So after you have done downloading, you can just open, and this window will open. So just click next and follow instructions. You'll be able to download QGIS. So basically, after downloading, you will find QGIS on the start menu. You'll find it on the topmost side of start menu. So just click to open. So I'll just open QGIS desktop 3.1.6. It can take a bit of time, so be patient. It's loading some plugins, settings. It's rendering map canvases so that you can use it efficiently. So here is the QGIS main window. So I will go and see how we can open new empty project. So just click on the new empty project to initiate project. So basically, I'll go through and show the main layout of QGIS. So basically, this top layer is called title bar. Then we have a menu toolbar, which is here. And then we have attribute toolbar, which is here. We have vector toolbar, which is here. And this blank space is called main map canvas. And this one below, it is called status bar. And this one, it is layer panel. So basically, it is important to understand which QGIS version you are working with, just in case you face any bug, you will know where to report. And you must report also your QGIS version for any contributor to be able to help you also. So to understand your version of QGIS, just navigate on the menu bar, then click help, then click about. You'll be able to see all the information about QGIS platform. So we'll go and see how to set project in QGIS. So to set project, you just navigate on menu bar, then on project, then navigate on project properties.
Hello, Frank. I'm
Yes.
I'm not sure if it's my screen only, but you are just stuck on the welcome to QGIS. I'm not seeing anything else.
Welcome to QGIS.
Yes.
Okay,
Yeah,
let me.
it's the same also even to me.
Do you able to see now?
It's still coming up. There is something, but it looks blank.
I think we can see your screen, but it's blank.
It's blank.
Yeah, it's we can see QGIS when you shared, but it was blank. I hope that's the way you wanted to start.
Okay. So you must be seeing a QGIS main window.
Yeah.
Okay.
Yeah, that one is visible. Yeah.
Okay, so I will turn back a little. So I was saying that this was the main QGIS canvas, and on the top most side, this is called title bar, and then this is menu toolbar, and this one is called attribute toolbar, and this is vector toolbar, and this blank space is called main map canvas, and this one is called status bar, and this one is called layer panel. So just like I was mentioned before, it is important to understand what version of QGIS you are using. So just navigate on the menu bar and click help, and just click about. You'll be able to see all the information for QGIS. So basically, I will go and demonstrate how you can set a project in QGIS. So on the menu toolbar, just navigate to project, and then click properties. Then be sure to select general on this left column options. So you can set a variety of options for your project. You can set a project file, you can set project home, a directory, you can set your project title. So let me set first my project home working directory. So I'll set it maybe to document. Maybe I will set it to document. Then water net online course. So that is my working directory. And maybe I will name my project file to introductory. Introduction to QGIS. So you can choose to select any color you want or any data layer just that you will just add it to QGIS. You can select background color. So the most important option to set is this on measurement. So you can set coordinate reference system for estimation of different measurements like distance and area. So you can select on coordinate reference system. Then you can opt to change unit for distance measurement. Maybe by default it is in meter, so you can choose to change, but I will not change it. You can choose to change unit for area measurement. It is in square kilometer by default, so you can choose it to change, but I will not go change it. So that is basically how to set the project in QGIS. After you have done that, you can just click apply and OK. And that you can be able to start using QGIS. So next, I'll go and explore what is plugin. As I said earlier, plugins are third parties development applications that are built to enrich some functionality that core function of QGIS cannot do. So basically, to access plugin, just navigate to menu toolbar, and it is here. Just click on plugin, then click manage and install plugin. Make sure your internet connection is on because it fetching plugin from online repository. So here is the main window for all plugins. So I will demonstrate how to use plugin, and I'll be using Quick Map Service plugin, a plugin called Quick Map Service. This plugin used to help add base maps to QGIS. So on a search bar, just search Quick Map Service, and it is here. Just click it. So you can find the description part of it. Quick Map Service used to add base maps. So basically, you will install it. You will find an installation button here, but I already installed it, so I will not install it. So basically, that is how you can install any plugin you want. So before doing any processes, you have to understand that is the process you are trying to use is in core function of QGIS, or you have to download and install other plugins so that you can use such a process. So I will go next and demonstrate how you can add layer in QGIS. And basically, we will be adding vector layer, specifically in Popo River Basin shapefile. So you can just click on the layer, then you can go to add layer, then add vector layer. And then this window will open, requesting you to close your file. So I'll just click close button and just navigate to where you save your file. You must have the River Basin data saved in your computer, so navigate to it. Then be sure to select shapefile extension, which is SHP file. This is the only file that QGIS understands. So just select this file and click open. Leave all settings by default, and then click add. As you can see, this is our shape for Limpopo River Basin. So it is important to understand the metadata of the data you are using. So to check for metadata for Limpopo River sub-basin, just right click on this layer and go to properties. And on this left column, be sure to select on information, and all these are metadata for Limpopo River Basin. And basically, it is important to check for CRIS, which stands for Coordinate Referencing System, which is EPSG 4326 WGS84 geographic, and it is as the extent of this one. So its unit is in degree. So that is how to check metadata for a certain layer. So then I will demonstrate how you can use the plugin that you have just installed, which is Quick Map Service. So these are tools for Quick Map Service. They appear immediately after you have completely installed Quick Map Service. So you can use this one to add direct base maps if you know them, but you can use this search button to search for any base map you want. So for this case, we will add Google Satellite. It's a Google product. So on this search bar, in this search bar, just type Google. And all options for Google base maps will appear. So just find the Google Satellite. It is here, Google Satellite Hybrid. So just click add, and it should appear on the map canvas as you see. So next we will go and see how we can change style, you can change color of this vector layer. So just right click on the Limpopo River Basin and then go to properties. Then on this left column, just navigate to symbology, is here. And then from color, you can manipulate any color you want. Then select any color, just click OK. And click apply. You will see changes appear on the map canvas. But I just select outline. I like this one. So I just apply and click OK. Okay. So that is how basically you can change the symbology of any layer in QGIS, if it's raster, if it's vector, as a procedure as the same. So I'll go for now to see how processing toolbox works. So to access processing toolbox, just on the menu bar, navigate to processing, then open toolbox. So as you can see, these are all processes that you can deal with in QGIS. And another relevance of QGIS is you can integrate with other GIS platforms, which are open source like Saga and Glass. And from here, you can set any process you want to deal with. So I will demonstrate one process, which is called projection. Now we can use projection from processing toolbox. So I will try to use projection. So just light on a stage, on this stage bar, just light projection. Do that to the following results. Then be sure to understand which data layer you're working with. For this case, we are working with Limpopo River Basin, Limpopo River Sub-Basin, which is a shapefile, it is a vector file. So the projection process that we work as this for under a vector general. So I will try to explain all the four processes. The first one is assign projection. Just double left click to this layer to open. So assign projection is basically used to assign new projection to a new vector layer. It creates a new layer with exactly same feature and the geometry as the input one, but assigned to a new CLS. And this defines shapefile projection, just open it. So basically this algorithm sets existing shapefiles projection to the provided CLS. Contrary to the assigned projection algorithm, it will not output a new layer. So basically the difference between assigned projection and defined projection is that when you use assigned projection to any data layer, you will change the CLS, but a new file will be created. But when you use defined shapefile projection, you will change coordinate reference system or CLIS, but no new file will be created. It will just modify the same file. Find projection is used to search for projection for any data layer. Basically, it is used when you have a data layer which has no CLIS, and probably you don't know which CLIS to search. So just use find the projection, and it will estimate which coordinate reference to use. It will give you a suggestion, and you can just choose. This project layer is an interface to assign projection and define shapefile projection. So you can use a project layer if you have a data layer that has maybe long coordinate reference system, and you want to project it to another collective coordinate reference system. So I'll be demonstrating on how to reproject this layer, because we have already seen the Limpopo River Basin have already assigned coordinate reference system. So we will use reproject layer to reproject the Limpopo River Basin to more accurate coordinate reference system. So under the input layer, just select Limpopo River Sub-Basin shapefile, and as you can see, its coordinate reference system is EPSG 4326. So under the target CLS, you have to select which CLS you want to collect this data there. So click on this icon, select CLS, and we will use CLS with this code 32736. So this is more accurate CLS for Limpopo River Basin, as you see on this canvas. It just covers the Limpopo River Basin, but the previous CLS, which is EPSG 4326, this CLS cover globally, and it is almost used for products that have global coverage. So we will project the Limpopo River Basin to more specific CLS that covers some portion of part of Southern Africa. So just select this CLS and click OK. Then under the projected, you can opt to save this file to your working directory. You can click to save this file to your working directory. That is, you can save this file to your computer, or you can just leave it to save this file temporarily. So after setting all options, just click Run, and you will see this loading result layer algorithm. The projected layer has finished. So this message shows that the process has completed successfully. So just cancel it, and you will see another new layer added on the layer panel. It is called the projected. So this is a new layer which has collected CLIs. So to confirm that, you can right click and go to metadata of this layer. Just on the left column, navigate to information. These are metadata, and on the CLIs, you will see IPSG 3273, 6 WGS UTM zone, etc. So our layer has collected projected. So I will stop here for today, because it was just a basic introductory part to QGIS, and all the demonstrations that I had shown will be using to estimate your water budget component. So basically, make sure you understand all of the process that I will you through, so that it will be much easier for tomorrow to catch up. Yeah, I would like to welcome maybe if there are any question.
Thank you so much, Frank, for a very wonderful presentation.
Okay, I see one
Yes.
question here.
Okay.
It say a lower version like QGIS 2.6 can't work for this training. Okay, actually it works, but it will be hard for you to catch up, because QGIS lower than version 3.0, there are some plugins that are missing. So basically it depends if Quick Map Service plugin and all other plugins that will be using are available under this version, but it is recommended for you all to have QGIS version 3.0 and above. I hope I have answered your question.
I don't think we have any more questions, Frank. Maybe you can close the session.
Oh, all right.
Sorry, maybe before we close the session, Dr. Gujinga, maybe my question is directed at you as a coordinator for the course. We have had some lecturers or some instructors, especially from KwaZulu-Natal. They said we are going to get their emails from slides that they were going to upload on the portal. But up to now, we haven't received any of the material, especially for the last one who did a presentation of Google Earth Engine. So we had some questions that we wanted to ask them, but we don't have the contact details. So I think you can also assist us on that.
Okay, that's fine. We'll circulate the contact details, and also we'll request for their presentations, and we'll upload them on the platform.
Thank you.
Okay, thank you.
Can I close the session, Dr. Gujinga?
Yes, you can. I hope Subira or Frank, you don't have anything to add.
Okay, maybe I can add something. I will share this manual to you. I don't know how. You will advise Dr. Gujinga, and it is important for everyone to download QGIS, because tomorrow we will work through on how to download those data and calculating water budget component. And it will be maybe a session for lifetime. So it is important for each and everyone to have QGIS version 3.0 and above.
Okay, that's okay, Frank. Once you share, I've actually asked Dr. Munishi to share a presentation and your presentation, so that we can put on the platform for everyone to access.
Yes, please.
Okay.
It's going to be shared right away. Right.
Okay, thank you. See you tomorrow, ladies and gentlemen.
All right, thank you.
Okay, bye-bye.
Thank you.